Welcome back, students, and we're going to be looking at working with exponents and radicals, but the second page, so on page 3. So rules for working with exponents and radicals. So you should have learned about these rules in Algebra 1, but for some of you it's been a few years since you took that, so let's look at all the different rules. So we have the zero power rule, which means that if you take a quantity, in parentheses like this, to the power of 0, it's always going to come out to 1. So all this here, 3 times a times b times c times 2 to the 0 power is 1. Anything raised to the 0 power is 1. So then if I have 5 plus, and then 19 minus 15bx plus y is all raised to the 0 power, all this cancels out to 1, which gives me 5 plus 1, which is 6. Next, we have the power rule, powers to powers. So that means that if you have something to an exponent, like a to the m, and then you have another exponent again, outside the parentheses, then you can multiply your exponents together. So let's take this example. We have 2 to the 1 power. So if something doesn't have an exponent written, it's really an exponent of 1. 2 to the 1 power times x squared times y to the third times z to the 1, because it doesn't have an exponent written. I'm just going to make the z prettier. Z, there. And that's all to the 4th power. So the way I simplify this is to take this exponent and multiply it by each of those exponents. So I get 2 to the 1 times 4, which is 4, x to the 2 times 4, which is 8, y to the 3 times 4, which is 12, and z to the 1 times 4, which is 4. So that's my expression. Or if we have this one here, so I have 5 to the 1 times x squared all to the 3rd power. So I have 5 to the 1 times 3, which is 3, and x to the 2 times 3, which is 6. Then I have the negative exponent rule. That means if you have a negative exponent, that's equivalent to the reciprocal of that number. So like for instance, if I have 2 to the negative 1 power, that's like saying 1 over 2 to the 1 power, which is just 1/2. Or if I have 5 to the negative 2 power, that's the same as having 1 over 5 squared. So notice the numbers kind of stay the same, but the exponent loses its negative when it moves to the denominator in this case, and that's the same as 1 out of 25. Or if you have one that's already in the denominator, so if I have 1 over 3 to the negative 2, let's say. What's the reciprocal of this? Well, since it's already 1 over, then that means this is going to move back up. So I have 3 to the power of 2, which is 9. So that's what this is doing. It's just taking whatever it is and giving the reciprocal of it. So let's try a few. So this exponent is only for the x. It does not apply to the 5 because there's not parentheses around the 5. So we're going to have 5 times, and then this becomes the reciprocal. So 1 over x to the 3rd power. And then we can simplify that a little bit more by multiplying here. So 5 times 1 is 5 over x to the 3rd power. Or we can try this one. So this negative 2 goes to both of these, the x and the y, but it does not go to the 3. So I have 3 times, and then, oh, check this out. So here, see how we have a power to another power? Just like here. So let's do that first. Let's take care of that power rule. So 3 times x to the 4 times negative 2 is negative 8. And y to the, this is really y to the 1. So 1 times negative 2 is negative 2. And then now these need to be written as their reciprocal. So 3 times 1 over x to the 8 y squared. And I can simplify that one more time if you can squeeze it on your paper. 3 over x to the 8 y squared. So that's your answer right here. And then finally, we have a little bit more complicated one. So notice the 2. I'm going to actually use 2 colors here. So notice this does not have a negative exponent. That's going to stay on top of my fraction. I know I'm going to have a fraction here. This is going to stay on top. That's a positive exponent. This is going to stay on top. And this is going to stay on top. So all those pink ones, notice that they either have an exponent of 1 or they have a positive exponent that's bigger than 1. And then in green, I'm going to have the ones with negative exponents. Those have to move down to the denominator because the negative exponent makes it a reciprocal. So I have 2x squared y to the third times 4 x to the 1 z to the fifth. And then let's go ahead and combine the 2 and the 4. So we have 8x squared z to the fifth y to the third x. Now this one can actually be simplified a little bit more using quotient rule, but for now we're just going to leave it alone. Product rule means that if you have 2 expressions or 2 exponents with the same base, then you can add the exponents together. Because here's why. If I take 2 times 2 times 2 times 2, and then times 2 times 2, well, I have 1, 2, 3, 4, 5, 6 of 2 to the 6th. And notice that's the same as thinking 4 plus 2. Or let's try it here. So I have a times a, and then times a times a times a, and then times b. So I really have 1, 2, 3, 4, 5. I have a to the fifth. So notice that's the same as 2 plus 3 times b. So there's my simplified expression. And then finally, let's look at quotient rule. So quotient rule says that if you have 2 powers with the same base, one in the numerator and one in the denominator, then you can actually subtract the exponent. So let's take a look at that. So if I have b to the fifth, I have b times b times b times b times b. 1, 2, 3, 4, 5. Over b times b times b. Well, some of these are going to cancel out. Cancel, 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 which leaves me with b squared. And notice that 2 is the same as 5 minus 3. Or if we try this one, I have 12 and then y times y times y times y. And then I have over 3y. Well, some of those y's are going to cancel out. Cancel, cancel. Those cancel each other out right there. So, and then 12 divided by 3 is 4. So 12 divided by 3 is 4. And then y to the 1, 2, 3, y to the third power. And so there's my expression.